Okay, more on classes and frequencies distributions. This is the end of this 2.3. So basically, we're considering two different kinds of data. Here we have, this is an example of tax on cigarettes. And they said the tax was increased from here, the federal tax. That means in the United States they have two types of tax. They have the state taxes and the federal taxes. I guess the federal government, I have to say, means the national government. So the federal tax was increased from this number to this, so like a lot. It was increased a lot. And this was expected to increase, of course, the federal revenue, the amount of money that government can collect, but also expected to save about 900,000 lives. Okay, so anyway, that's interesting. But the table 211 shows the total tax, the state plus the federal, per pack of cigarettes for all 50 states as of April 2009. So let's look at my state, which is Pennsylvania. So $2.36 for that's pretty much, but I think in Japan it's a lot more, but I'm not sure about that. So anyway, these are the different amounts of money. Let's see, New York is even more, $3.76. Okay, so this is the data. There's 50 states, so there's 50 taxes, so there's 50 pieces of data. So we're going to compare, we're going to do one thing for this kind of data as compared to a different kind of data down here. So here, the administration of a large city wanted to know the distribution of vehicles owned by households in that city. So in other words, how many cars, I guess cars or maybe motorcycles are included, owned by households in the city. A sample of 40 randomly selected households from this city produced the following data on the number of, so the first family had 5 vehicles, the next one had 1, the next one had 1, the next one had 2, the next one had none. Okay, so we have this data here. Okay, now this data here is kind of different than this data here. Okay, for one thing, I mean basically, you know, here we can get lots of different kinds of numbers, right? Many different types of numbers, many different numbers, I should say. Whereas here we basically only have numbers between 0 and 5. Okay, and we don't get values, fractional values here, right? We don't have 1.2, 1.3, right? That you don't have 1.2 vehicles in your family. Okay, so we're considering these two different kinds of data and what we should do to make a frequency distribution in these two cases. So how should we handle this one versus how should we handle this type? Okay, so what they say is for this type we use the so-called less than method for writing the classes. So what they mean by that is that, so they say the minimum value in this data set on cigarette taxes was $1.08. Okay, so that's one of the states had only $1.08 of tax. And the maximum value was, I guess this was New York, was $3.76. So we have that data that runs from here up to here. So we need to decide how many classes we're going to make. And they say, suppose we decide to have 6. Then the approximate width of a class, remember, how do we get the approximate widths of the classes? We take the highest piece of data minus the lowest piece of data, and then we divide it by the number of classes. So we get 0.45. We round this number to a more convenient number, 0.5. So we're going to make the width of each class 0.5. We can take the lower limit of the first class to be 1.08. That's the lowest number we had. If we start the first class, there can be any number lower than that. So they're actually, because that's kind of an inconvenient number to start a class at, so let's start it at 1 instead. So the classes will be written then, and this is what they mean by the less than method, and that's when you have these kinds of numbers like lots of fractional numbers and so forth. The less than method means we started at 1 and the class width is 5, so it's 1 to less than 1.5. Okay, so not including 1.5. And then 1.5 to less than 2, not including 2. The 6 classes which cover all the data values are recorded in the first column of table. So that's what they mean by the less than method. So table 2.2 here, 1 to less than 1.5 and so on. A value in the data set that is 1 or larger but less than 1.5 belongs to the first class. So it's in between here, it goes in the first class. The relative frequencies, okay, so that's called, so then you just do the relative frequencies and the percentages the same way. So that's called what they call the less than, what does they call it? The less than method for writing classes. Okay, then the single value classes. So what they're going to say here is, we only have how many different values here? We have 0, we have 1, we have 2, we have 3, we have 4, we have 5. So that's 6 different values. So in that case, they say, let's not do intervals per se. Let's just do points. So they're saying, so what they mean by that is, how many, so points means no, not an interval. How many zeros were there? How many ones were there? How many twos, threes? So these are not intervals, right? These are points. So then they're going to get this kind of graph. Okay, so what do they say about this? If the observations in the data set assume only a few distinct integer values, it may be appropriate to prepare a frequency distribution table using single valued classes, right? So we just have one. The classes are just 0, 1, 2. It's not an interval. Single valued classes. That is, the classes are made of single values and not of intervals. This technique is especially useful in cases of discrete data. Discrete means, I think we talked about that word. Discrete means not continuous. So with only a few possible values. Okay, so this example is an example of that, as we saw. And they do this. They do that. The frequencies here. And then you can do this like this. Okay? So that's the end of section 2.3. Let's stop here.